Let's solve some basic probability and counting questions together. Let's start off with our first question. A standard deck has 52 playing cards. What is the probability of drawing a queen or a heart? So if you know our general probability formula, it is your favorable outcomes over the total amount of outcomes you can have. It's written as a fraction. So using the same general formula, let's find the probability for the situation. So the first fraction would be 14 over 52, because out of 52 playing cards, 14 of those could be queens, so that's our probability there. And then of 52 playing cards, 4 of those could be a heart. So if we simply add these up together, you get 18 over 52, which is our answer for this problem. Notice that the reason we have an addition sign here is because we are asked or, and I want to talk more about this later in the video. Additionally, one more point I want to bring up is that some people might think we have to subtract 1 over 52 because we're overcounting in this problem and we need to not include the Queen of Hearts. However, in this case, we would include the Queen of Hearts because it still meets our criteria of being a queen and a heart. So we don't need to subtract the 1 over 52 for overcounting. Let's move on to the next problem. A spinner has 3 red, 2 blue, and 1 green section. You spin once and then roll a 6-sided die. What is the probability of landing on red and rolling an even number? So we see that the spinner has 3 plus 5, which is 3 plus 2, which is 5, and then 5 plus 1, which is 6. So 6 total sections, and then 3 of those are red. So that's our probability for this first part of the question. And then for a die, we know that a die could result in 1, 2, 3, 4, 5, or 6 as its final outcome. And then 2, 4, and 6 are the even numbers of all the outcomes. So the probability of getting an even number from rolling a die is also 3 over 6. So if you multiply these together, and I'll explain why in a second, you get 9 over 36, and then our final answer is 1/4 for this problem. The reason you multiplied this instead of adding it up is because we are asked for an and. So essentially, when a probability question asks and, you would multiply, and then when it asks or, you would add them together. Okay, how many ways can you arrange the letter in the word access? So we know that access has 6 letters total, so that's 6 factorial, 6 ways you could arrange them. And then we don't want to overcount because we see that there are 2 C's here and then 2 S's here. So in the denominator, you had 2 factorial times 2 factorial to make sure you don't overcount. So when you simplify this, you get 720 over 4, which is equivalent to 180. And that's our answer for this problem. And then from a group of 7 students, how many ways could you choose 3 to form a team? So popular notation in counting and probability is a choose notation. So out of 7 students, you want to choose 3 to form a team. So a way you would rewrite this is 7 times 6 times 5, and then 3 times 2 times 1. So the denominator is 6. And then if you simplify this, you get 7 times 6, which is 42, and then 42 times 5, which is 210. So if you simplify this, you get 35 as your answer to this problem. And now our final problem here. A password is made by selecting 2 letters from A to Z, followed by 3 digits from 0 to 9. How many unique passwords can you create if letters and digits can't repeat? So we have a 5-digit password here, and then we want to use 2 letters. So we know that there are 26 letters total, so any of the 26 could be for the first one. And then, however, we would have 25 in the next one because digits cannot, letters can't repeat. So once you use one, you cannot use it again. And then followed by the 3 digits, there are 10 digits total. And then there would be 9 because you don't want to use the one you already used. And then there would be 8 because you don't want to repeat these 2 digits. So if you multiply all of these together, I think you will get, let me just pull out my calculator really quick. 5 times 10 times 9 times 8. So this is equivalent to 468,000. And those are the solutions to this problem.